Okay, this is the second installment of this implicit functions derivative lab. And the first video I did, I covered 1, 2, and 3. So I'm going to go, so I don't make this video too long, but it goes to 8. So I'll go as far and I might do one more video. We'll see how long this one lasts. So again, implicit differentiation happens when you have implicit functions where the x's or your variables are mixed, your x and y's in this case are mixed. So I have e to the sine y equals x cubed times cosine y. So the first thing I want you to recognize is that this is the product rule over here. So there's our f and g's. So I'm going to set up my f as x cubed. My f prime is going to be 3x squared dx, the derivative with respect to x. My g is cosine of y, and g prime is going to be negative sine of y, derivative with respect to y, so it's dy. Again, I've said many, many times, I know there's other ways to do this where you don't put the dx and you write y prime here, but this will help you later on with related rates. I've said it 100 times, so I'm not going to keep saying it, but I'm going to tell you this will be helpful. So I'm going to go through and do the derivative. So the derivative of the left is I'm going to rewrite. Don't touch the baby, times the derivative of the top, which is going to be cosine of y. And it's dy because the derivative with respect to y, so that's the left. The right is going to be the product rule, so I'm going to do f prime g. So I got 3x squared cosine y dx plus f g prime, so it turns negative, x cubed sine y dy. So I have all the terms that I need here. So now I can go through and divide through by dx, because remember, we're looking for the derivative of y with respect to x. We're solving for that. So I'm going to divide through by dx. And as you can see, the dx, thanks for playing. So now I have e to the sine y, cosine y, dy dx. And I'm going to move over this x cubed sine y over here on the left, okay? So that's going to be plus x cubed sine y dy dx as well. And it's going to equal the 3x squared cosine y that was already on that side, okay? Lots of times in this step here, I'll factor out the dy dx at the beginning, and that's fine. I'm going to do it now. Just saves you a step. So I'm going to factor out the dy dx out of both these terms. I have e to the sine y cosine y plus x cubed sine y equals 3x squared cosine y. And then these are hooked by the dy by multiplication, so I'm going to divide by the glop. So dy over dx, or the derivative of y with respect to x, is 3x squared cosine y divided by e to the sine y cosine y plus x cubed sine y. So there's my derivative. I always like to stop and look at it and feel proud. And this is some of the homework that you'll want to leave on your kitchen table for your family to see that you can do implicit differentiation. And the other thing is I try to look at it if I can simplify it, and I really can't. So that's my answer. So that is number 4. All right, I'm going to do number 5. Number 5 is pretty short. And number 5, the reason why it's short is because I don't want you to forget your trig derivative of your trig identities. And if you'll look at here, cosine squared plus sine squared y, I know, is equal to 1. That's an identity. So I basically have this. 2 equals y cubed. All right, so I can write it like this, y cubed equals 2. And because we're used to doing implicit on this one, we're just going to go ahead and do that. So I'm going to write that as 3y squared dy, and the derivative of 2 is 0. Go through and divide through by dx. And so I'm going to solve for this. So I'm going to divide both sides by 3y squared. I get dy over dx equals 0. So you can do something as simple as that, even if you have one variable. It's kind of fun, and that's a quick one. So that's 5. Let's do 6. So let me clear the ink from this page. We're going to do 6. I'm going to kind of come up here a little bit. This is why this needs to be done in your spiral notebook, because you really don't have room. So I have the tangent of xy squared equals x squared y. Again, I want you to recognize that you have a product going on inside that function, that trig function. You have a product here. So we can set them up over here on the left and get it all set up so that when we go to have to do the derivative, I just like stacking and racking my product rule type functions, because it really does save a lot of time. It's organized. So my first f is going to be x. F prime is going to be 1 dx. G is y squared. G prime is going to be 2y dy. So I just did what was in here. My second one is going to be f is x squared. F prime is 2x dx. G is y. G prime is going to be 1 dy. So we're all set up to do the derivative of this function way up here, number 6. So let's do that. The derivative of tangent, I know, is secant squared. And I'm not going to touch the baby, so whatever's inside is going to stay, times, and then I've got to do the product rule because the derivative of the inside is a product. So I'm going to come down here, and it's the first one we're going to do. We're going to do f prime g, so I have y squared dx plus fg prime, so it's plus 2xy dy. Okay, and I'm multiplying by that. That's what that side is. Equals, and then we have the other product rule right over here. So we're going to do f prime g. So I have 2xy dx plus fg prime, or x squared dy. Now right here is where everybody wants to go through and go ahead and divide through by dx. I would not suggest it at this time. What I would do now is multiply this through so I have all my terms. This is one big term. Let's make it a little bit nicer. So I'm going to write it like this: y squared secant squared x y squared dx. So notice I just kind of put this in the front and put the dx at the end. I know it's going to go away. Plus 2xy secant squared xy squared dy. Okay, so the left is done. I have my two terms. And the right is going to stay the way it is going to be 2xy dx. Whoops, I'm running out of room. Plus x squared dy. All right, so I'm going to move this down a little bit. Now that I've used this, I'm going to get rid of it just so I have some room. Now I've got 1, 2, 3, 4 terms. So now I can go through and divide through by dx. When I do this, thanks for playing. This one's gone. Here's a dy dx. Divide this one by dx. Thanks for playing. And this one is a dy dx. All right. So now I see that this term right here doesn't have a dy dx, nor does this one. So I think what I'm going to do is move this over that side and move the dy dx's on the left. So I have dy dx. All right. I'm going to factor it right out of this first one. So I have 2xy secant squared xy squared, just saying that. And then because I move this over here, I have a minus x squared. Okay. Equals what's left over on this side on the right is just 2xy. And then I'm going to move this y squared secant squared xy squared over on the other side. Say that twice. Y squared secant squared. Get that out of the way here. Secant squared xy squared. Okay, so I just got them all isolated that I want, and now I'm going to divide by this glop. So dy dx of number 6 is going to equal 2xy minus y squared secant squared x y squared all over, all right, 2xy secant squared x y squared minus x squared. Okay, now this one right here, I actually could try factoring out a y in the numerator, and on the denominator I can factor out an x, but it's not really going to help us any. Sometimes if something would cancel, it makes it nice, but I'm going to just leave it like that. And I'm going to make one more video that will do the tangent lines, which is 7 and 8. So this is the end of the second video on this lab. So let me bring this back and stop it.